Hello everyone, welcome back. My name is Mark and this is Mark's Coding Project. This is video number 34 in our Java tutorial series, and today I'm going to be talking to you guys about how I used methods and arrays to solve a problem that I had with my code. So the problem that we had was that whenever we made a move here, so you see we've got our getMove method, there was a chance that the user might enter an invalid input. So they might enter a value which is either too high or too low. Because you'll remember we have numbers that correspond to columns in our Connect4 board. We only have a certain number of columns, numbers 0 to 6. If we go beyond that, then it will cause an index out of bounds exception. And we don't want to do that because it will break our program. So we need a way of, first of all, stopping the user, sort of handling what happens if the user enters a a value that's too high or too low. And then on top of that, we need a way of re-executing the method so that they get a chance to enter a valid input. So there's a combination of things that I want to talk about. First off, the first part of this problem is what to do if the user enters a value which is too high. So how do we identify that? Well, what we've got this if statement, and it checks. So it says, okay, well, if move 0 is greater than 6 or less than 0, then this is flagged as invalid, and we have set those conditions in place. The next thing that we're going to do is we're going to set move equal to 10. And the reason for that is because our entire sort of section for how to get a move from the user is been put inside of a while loop. So if the user enters an invalid input, the move 0 value will be set to 10 and the while loop will loop back around and ask them for a new value. So that's how we're getting the repetition effect. So every time you enter something invalid, the program will just start again and it will say, okay, enter another value, and just keep doing that until you give something that meets my criteria. So where do our arrays and our methods come in? Well, you'll notice that this value is not an integer. It is, in fact, it is an integer, but it's an integer inside of an array. So our array move is up here. Our array is going to contain the user's input, so the column value, and it's going to contain the row where that value will then be placed within the column. That counter, will be placed within the column. So we're using an array because we want to store multiple values processed by multiple methods. So row move 0 is going to contain the output from our getMove method. So our getMove method, before it was just a return type of integer, and it would return the column value that the user had entered. So it would just take this, store it into an integer, not an integer within an array, and it would return that. Now it's being stored in an array. The reason for that is because we've taken that value, put it in an array, and then the next value that we're going to add to it is our return value from getRow. So getRow still returns an integer, and that integer is going to be saved to our second element in our move array, and then we're going to return the whole thing. So in this instance, we're using arrays to store multiple outputs from different methods. The reason for this is because if we tried to execute the methods independently of each other, we would have two different integers. So say we had integer move, just for example, it'll give an error, but ignore that for now. And then we have int row. Let's get row. Well, row and move are dependent on each other, or at least certainly row is dependent on move. So I think the main problem with this method is the fact that if we want to execute getRow inside of getMove, and we do pass move as a parameter, and I think the reason this is being done is because they do sort of correspond. So it makes more sense to do validation checks on a single data structure than it does to do validation checks on move, pass it to row, and then do validation checks on row. And in addition to that, by doing it this way, if say our row fails, we can't keep doing row, because if our row fails, then that means our move is also invalid. So we need to execute get move again if we need to re-execute get row. And so yeah, that's the main issue, is the fact that get row has to come with a get move, and if get move is valid, in the previous solution get move wouldn't have been executed, and putting a get move inside of get row wouldn't have done anything, and it just would have made more problems. So this is the best way of doing it. So what happens in this new solution is that our output from get row is saved to our get move, and that whole thing is returned as our output from get move. So we have one variable storing both of the outputs rather than two. And then secondly, we're then able, by doing that, to execute our get move, because our get row is inside of get move. So that's how we ensure that get row is executed again, should it fail. Because in the previous solution, we had get move, we couldn't put get row in it because get row was saving to a variable outside of get move, and so we couldn't execute get move again because they were sort of independent, even though the functionality is actually quite closely linked. I think I am going to make a change to this code while I've been talking to you guys. Some of you may have spotted this already, but I'm wondering if get row is really necessary. So I think the array is necessary. I think having get move as a single method is useful, because again, we've got that ability to use recursion. So if get move fails, we can execute it repeatedly until it succeeds. That's great. But get row, first of all, we're not executing it recursively, so there isn't that benefit to it. And second, so to be honest, I mean, that's the only real benefit. All it's doing is it's doing a calculation. We're not using it recursively. It's not doing anything independent of get move. All of what get row does is dependent on get move. So what's to stop us moving the get row code into the get move method and then saving that output to our get move, to our move array? There we go. So having said all of that, what I think I am going to do is I'm going to copy all of this code. Okay, so what's happened is I've said if our move is valid, then we're going to move on to the row functionality. Our row functionality loops through our column and it says, okay, once you find a slot that equals 0, then return a value. Sorry, not return a value, then set row equal to that slot which is available. So this is our row value, as it says. And then we're going to save that to our array. And then finally, we're going to return the array. So we've got the same functionality. What I'll now want to do, I hope, fingers crossed, if I delete this and I put an else statement here, I think it's going to have to be an else if. So else if y equals 5. So if we're on the final element of our, if we're on our final column value, and this statement isn't met, then clearly the entire column is full. We will print that out to the user, and we will repeat this function's execution. Okay, so far so good. Some of you may be wondering where the GUIs have gone. I've just minimized them because we can test this using our console. That's a fun new bug that we found. I have no idea where that's come from. Cool. Okay. Interesting. column is full. Cool. You're gonna let me move? Wow. Okay, you're really broken. Okay, so I found the problem. In the method version that we had, once we found a slot to put our, once this statement was executed, we had a return statement at the bottom. And what return statements do is they exit the method that you're in. So if I put a return move here, that should solve my problem. Yes, there we go, happy. So what was happening was, in the previous time, it was looping through, so it's going, okay, well this value equals 0. And then it was looping through to the next one. Okay, this value equals 0. Okay, this value, it was going all the way to the top. It was saying, okay, that value equals 0. It was assigning it, and then it was terminating the loop. So it was setting each one equal to the one value, and it was overwriting it every time, if that makes sense. So this value is equal to 0, and then it was set to a 1. No, sorry, so this value was set to the row. Yeah, so row would have been equal to 0 on the first time I ran this. So from player 1's perspective, this would have been 0, but then it would have checked this one as well, and then that would have been, and then row would have become 1, 2, 3, 4, 5, and then the for loop would have ended. Now we are returning our move immediately, and that's not happening. So the minute it matches with the first 0, it terminates the method, so it doesn't check all of these, which is working. So the next thing is, does it work if it's invalid? So it recognizes it's valid, it asks for a move again, find to 5, boom, it works. So we now have our counter in that slot. The final test is going to be if our column is full, what happens? I'm going to try and get player 2 to do it just to make sure. Perfect. Because it could work on one player and not the other. I don't know why, but it's an extra thing to test. So column is full, wage on space counter 2, and that hasn't worked. 2. Okay, so what's, for some reason when we re-execute get row, I think our previous value is probably being retained. I guess that would be my guess. Oh, it has. Oh, I'm so dumb. Yeah, so you can tell this value, so it's converted, because so we entered 3, 0. 3 was full. We then entered 2, and what it did was it said, okay, 2's empty at 0, but it saved 3, if that makes sense. So the coordinate became 3, 0 rather than 2, 0. I can illustrate this to you in the code. You see, I'm not entirely sure why it didn't overwrite. That is confusing. I feel like it should, because it would have set move equal to 10 as well, which is really bizarre. Crikey, this is baffling. Oh, could it be because we returned move? Potentially. So what I've done is I've switched our recursion approach. So instead of executing the whole method again, we're just going to reset our move value. Oh, that's my GUI. A lovely shade of green in there for you. Okay, this is going to be interesting. I'm curious to see what happens here. So what we've done instead of going and executing get move again, we've just said that move equals 10. And hopefully that means our while loop will trigger and it will ask our user for new input. Much the same way that if I enter a 7 now, it'll ask me for new input. So, okay, cool. And that works fine. So I'm very curious to see what happens now if I do this. Bang. It works. Fantastic. Happy days. Yeah, that's most of it. I did want to say a really quick thing. So with my GUI, you'll remember my tokens were placing all over the place. I'm going to give you a really quick demo on how I fixed that. So I've made a few changes. I'll go more, probably do another tutorial on this because it doesn't really relate. But we set up our height and width differently. So now the tokens are reconfigured so that they count up the board. So they stack on top of each other rather than cascading down, which is good. It's like a proper Connect 4 board. We changed one of our images. So our red image, you remember it looked horrible, wasn't working properly. So we had to change it. But the biggest thing, so the reason why we had those counters like placing at the side of the screen for no reason was because Java by default sets a layout. And the layout kind of takes priority over your personal location settings. So my thinking is that was why our set location method wasn't working. Is because Java was like, okay, well, you have a layout already installed, I'm already configured, so I'm going to follow that. And it's a default, so I didn't configure it. So what I've done is I've removed that. So by doing that, I have total control over the positioning of my images. And now you'll see we kind of have a working solution. You remember our input is still done by command line. Well, I say command line, by console. So I'll make a few moves and then I'll show you, it will come up on screen what it is we've actually got. So just enter a few different columns, there we go. Boom, okay. So it's not foolproof, but hopefully if you remember it's much better than what we had before. So my plan is hopefully maybe enlarge these, line them up a little bit better with the columns, so the spacing should hopefully work a bit better. It will be a combination of the different parameters that we've got. So you can set the size of the label. So I think that might be something that we can do. So I think there's like a space around this, like a square space around this, which defines the label's area. I think that might help push these ones to the side. And I think I might try and drop a couple of them, or maybe this top one, move it up a little bit. Basically, we need to get the ratio correct. So there's the spacing between the counters versus how, like the overall how much we're incrementing by. So say we want to move up by like 50 or something every time. That needs to be worked out in relation to like the boundaries and the sizes of the counters, because we can shrink the board, we can enlarge these images potentially to try and make them fill out the holes a bit better. It is going to be quite fiddly. It's probably not going to be done on camera, but I just thought I'd show you it is progress, which is good. So if I make another move, just to show you that I'm not cheating, column number 1, bang, there you go. Again, slightly off. But yeah, we'll work on positioning. I'll work on positioning and I'll show you guys the final finished counters actually look decent solution. But that's all I've got for you for today. So thank you very much for watching. I hope you've enjoyed it. I'm going to be trying to stick to this new format because I think this seems to be the best way of doing things. So illustrating programming techniques using real world programming problems. So this is, I didn't make this up. This is like a genuine problem I had with my code. And I think that's probably the best way to teach you to program. It's basically, here's a real problem and here's how I solved it using real techniques, not just some textbook like, oh, here's an if statement and here's what you can do with an if statement. This is not very, you can't really apply that as well. But let me know what you think. The code will be available as always on GitHub, and any questions, please do comment down below. Any feedback, again, comment down below. Please do like and subscribe, or dislike, yeah, that's fine. And I'll see you guys in the next video.